We are not late, Daniel. It is still 6 o'clock on the dime for me. I don't know what it is for everyone else. How's it going, everyone? Hey, Bradley, Sion, moo to you. Daniel, what's up? Heed, how's it going? Bit Bastili, how's it going? It's good to be on time. Hey, Mako, I already said your name. Hey, question. Is my audio out of sync from the video? It always seems like it is, and that's actually something I have never asked before. Yes, went with the Halloween stream theme. You can thank my girlfriend for that one. I'm pretty happy that the it is a tad out of sync. All right. Well, I'm not going to spend a ton of time with this, but I can adjust the offset a tiny. So tell me if it is better now. Okay, is it better or is it worse? Hello, test 1, 2, 3. Hello, hello. Alright, so I'll see if that made it better or worse. It sucks because it's like every not worse. Okay. But is it still out of sync a little bit? Because what's funny is on my feed, it actually looks worse now. A bit more of whatever I did. All right. Let's try. Okay, how is this? Test, test, test. Hopefully that's better now. I did the exact same amount that I did the first time, so presumably that makes it better. We'll see. Good for you, Bruce. All right. Hopefully it is for everybody else. What's funny is because I had to have that offset how it is good enough. All right. Okay, cool. Yeah, it is weird how it's always out of whack on my end. But anywho, all right. So for this stream, so basically I just posted this in Discord. So you're not showing your person anyway. I know. It's kind of funny. It's only at the start, but whatever. So this is the hot plate that I currently use for pretty much all of our prototypes. It's like the greatest thing ever. And it's simply just a aluminum extrusion that has 2, 4, 6 high power cartridge heaters that go into the aluminum plate. And these, I have tried everything in my power to find to try to find where I bought them from. It was like 3 years ago to get the exact specs on it, but I can't find it. I'm pretty sure they're like 2 amps, 2.5 amps each at 115 volts AC. Obviously, I can measure it, but they're all connected and parallel, so I'd have to disconnect that. But basically, yeah, just super high power cartridge heaters here. And right now, this all just goes to a single plug that I plug into an outlet. And then there is obviously the mineral wool that keeps it from burning up whatever's below it, which obviously mineral wool isn't the greatest thing to be breathing in. So it's kind of really janky right now. And I don't have a way to control the temperature. So basically, it's on a switched outlet. So depending on what type of solder I'm using, but I will typically put the board on and then turn it on a switched outlet. And then once it's going, it will take like 3 or 4 minutes to reflow. Or if it's higher temp solder or a denser board, I'll sometimes start it heating, then put the PCB on it, but it just depends. So, how do you cool the plate, or you don't? You heat it up and wait till the paste reflows and then take it off the plate. Yeah. So right now, once the board's on it, it's heating up. When it reflows, I'll unplug it and then wait till everything reflows. Then I quickly take the board off, which obviously isn't a ideal setup. I also had this modeled a while ago, but that was back when I was still using SolidWorks, so I kind of lost it. So I'm just going to quickly model this, and then I'll kind of go over what the game plan is to make it better. And I know I could do just a linear array here, but for just 6 things, it's normally quicker to just do them separately. So they are 1 3/8, right? Yes. Sorry, still in a small window as the chat type box. Oh, gotcha. Oh. Actually, since it's probably not exact, I am going to base this on. How's it going, Tamas? Tamas? How do I pronounce your name? I'm sure I mess it up like every time. Oh, come on. Okay, so I need to make all of these equal. Oh boy. Oh boy, now I've done it. Okay, I believe that's good, and now it should just be needing to constrain these. Yes. Okay. Came running back to mechanical design. I know, right? And by watching me clumsily go through this, you wouldn't really even expect that, but it is what it is. Okay, there you go. So let me see what this actually is. How accurate? 1.3. Okay, so my measurements were pretty solid. Yeah, it's like through school, like I got certified in SolidWorks, and that's what I had been using. But once I was out of school, no longer can get education and would rather not use that for work. So Fusion it is, which honestly, for a lot of things, it's honestly better that way. Fusion is pretty fantastic for smaller assemblies, but for anything else, SolidWorks is obviously better. If you try to pronounce it as Tamash, Tamash, Tamash. See, that didn't help me at all. Okay, so basically, here is our hot plate, and let me make this its own. Let me make it its own component, and then we'll rename it hot plate. And for now, Fusion is hands down my favorite, but have you used SolidWorks? Until you've used that, I mean, that's one of the gold standards, at least for non-simulation heavy. It's a pretty good standard, but okay, so I grounded this. So the plan is kind of twofold. One is we need to get it off of that mineral wool, so we need to have a way to elevate it. And then to Sion's point, I don't think we're ever going to be able to cool this down fast enough to where you can keep the board on it. While that would be really nice, I don't think it's possible. It would be really nice to be able to use a fan and cool this off faster. But also, there's a lot of thermal mass still in here, which makes it heat up cooler. So one thing I'm planning on doing, and this isn't going to be a focus of this stream, but I think I'm going to get sections like this milled off of here to make it much, much less thermally massive. So it'll heat up a lot faster, and then it'll also cool down, especially with a fan. So that's something in the future. I've tried using, but the learning curve was a bit rough. Oh, for sure. The learning curve is, but I don't know. It was honestly painful going to Fusion the way because SolidWorks is so part based to where you make all of your parts separate and then add them into an assembly. Here you do it together, which I think is much faster for stuff like this that's super simple. But for bigger assemblies, this becomes a nightmare, which is why SolidWorks is still used a lot more in industry. But yeah, either or. Electrically triggered liquid nitrogen injection. Oh, trust me, I've thought of water. So, good point. I've thought of attaching like some water cooled brackets here or manifold so then you can cool it with like a computer water cooling system. But other than obviously having to worry about the water or whatever you're using boiling off, any metal that's added in here is going to make it more thermally massive. So we could do holes in here and pump fluid in, but I don't think we're still going to be able to cool it down quick enough. And it's so inefficient having to heat it up each time fully for every board. So I don't think that's going to work. Why not just control it with an SSR like a heated print bed? Bruce, you're jumping the gun. I'm not there yet. Could PID? Yes. So to summarize, two things I want to accomplish. One is build a stand for this so it no longer is sitting on mineral wool. And then the second is to design the electronics for this so we can use whatever controller, whatever microcontroller. And once that is set up, it'll it really isn't going to be able to follow a reflow profile because it's going to be full on power until it gets to reflow temperature. But at least it might be able to keep it at that. And then when I switch it off, potentially having fans at the bottom to help cool it off. Because essentially, normally we use this since we have two industrial reflow ovens. This is just used for like prototypes and one-offs. So like at most we would do like 4 or 5 boards in a row. So just being able to cool it off like to a reasonable temperature, maybe like 100 C, to where we can follow a better profile, that would help. But we'll see. So my plan for the enclosure is to use the aluminum T-slot framing rails and build like a little frame around it that lets us put all the fans underneath it. Sion, I've Hevro hot plates. They just can't drop temp now long enough, but having some electronics better than just on full. Oh, for sure. And like I said, my goal isn't to cool it off completely because I just grabbed the board off. Again, we're not using this for any amount of numbers. So if it can reflow 1 or 2 boards, we're good. Because any more than that, we're just going to use our regular oven. So that's pretty much all it's made for. So I am going to grab, I guess, just a foot step file. And I have a decent idea of how this is going to work. I've been kind of thinking about this. I've wanted to do this now for probably 2 years now. It just never has happened. So that's kind of why I decided to do a stream of this because it kind of forces me to finally do it. But I still don't have all the, especially electronic side, I don't have fully sorted. But yeah, hot plates for prototypes, I think, in my mind, are by far the best way to do it. With the only exception if you're doing any double-sided boards, obviously you can't really do it on a hot plate. But short of that, they work. Come on, why is it not letting me drag it in? Um, I don't know why it's not letting me. Why is it not letting me drag in? I don't understand. I can't show my side panel because I have other projects, but normally you can just drag in the other file. That's just a step. Um, I have no idea what's going on. Let me see if it's because I have two windows open. 1 second. Okay, I have no idea why when I have a imported. Oh, really? I can do them directly? That would be amazing. So how do you do it? You go to through the insert menu. Where's the insert? Oh, right here. Are you serious? Okay, well that's really cool. I never knew that was a thing. Well, I appreciate it. Or anything SMD with through hole pins, like some USB. Um, did you say something above? That's like a part of a message. That is so cool that you can do this directly. That was something you could do with SolidWorks. I didn't know that you could do it here. That's really cool. Okay, no, not 10 millimeter. 20 millimeters, the smallest, still standard size. So 1 foot. So I'm assuming, do I still do 3D step, I guess? Oh, that is so cool. I appreciate that. That's really helpful. Except, all right, sweet. Okay, cool. Okay, so what I am thinking of doing, and I guess I'll show you what I'm also going to be doing. Oh, that's I guess one annoying thing is you have to go back and find it each time, where if you're downloading them separate, you get to kind of keep it open on your monitor. But I guess beggars can't be choosers. Okay, so basically using these brackets, and I'll obviously properly mate these later, but just kind of showing you the gist of it. So basically, these are going to hold up this hot plate. These are threaded, which is kind of annoying, so I'll just end up drilling these out because obviously if you tap both sides, then it's going to pull itself apart. So I'll drill these out and then tap a hole in the extrusion. So this will be held up by the screws here. And I'm debating what I do with the washers because since this will be tapped, it'll already have a thermal connection to it, which I don't want to have. But I guess if I don't really have a choice and it has to be thermally connected somehow, I could still put a like a ceramic washer, which will help insulate it because I just don't want to have a lot of heat getting from the hot plate to here, because it's gonna make it take longer to heat up. But yeah, that's essentially what the plan is for making the corners of this. That part I have not thought of yet. Nylon washers, yeah, you can't use nylon. Nylon will melt, but yeah, you can use ceramic, which are thermally isolated. The problem is the actual screw is going to be tapped on the aluminum, so there's always going to be a thermal connection at some point, and PEK won't be nearly hot enough or won't withstand heat, so I'll have to use some sort of metal. Cyan, you can mix metal, stainless. Yeah, that'll help some. Either way, it's going to transfer some heat, but I'm not going to be too bothered. It's going to be, I'm only going to have to use, I think, 3 screws, so it really shouldn't be a big deal either way. So for the brackets, so for the corners, there's usually 2 different options. Normally these work pretty well. I think they have a three corner one. I guess it's just 4. So, oh yeah, this is 3. So yeah, just using these in the 4 corners, that probably will work. Oh, and I bet I can do this. Just copy the part number, and now I can insert this much, much better. Or quicker, rather. Oh yeah, that's awesome. Man, that's like a game changer. That's such a big deal. Like, that makes it so much nicer. Okay, so, and then the only other thing that's kind of a pain is on the end that the heater wire sticks out, it has a radius or a distance of like 1.5 inches before it can start bending down. So we're going to have to extend the length on that size somehow, or to some extent. So that's going to be a little bit annoying. And I'm just trying to figure out now which way makes the most sense to start. Probably with the extrusion, I think. Let's see. Glass rods, use those wooden. What kind of grammar is that? Glass rods, used kind of like those wooden plugs IKEA's such a fan of. Oh, I like that. I like that. And what we can even do further to make sure, not that it's going to be jostled around, but to make sure the metal plate can't lift out of it, we could probably use like some non-thermally conductive goop that's high temperature enough to withstand it. I really, really like that idea. Yeah, I think that probably is the game plan. So basically what I'm thinking is, like I said, we're going to have this side sticking out by like 1.5 inches, and then the wires are going to come out and then drape down where all other 3 sides will be flush. So, or flush-ish. So I'm thinking just do it kind of arbitrary for now. And I guess let's mate this at least on 1 to know what the distance should be. You need a cheat sheet list for the partners. Yeah, right. Yeah, it is funny all like the random stuff that I learn from doing these live streams. Like, it's insane. Because it's like, it doesn't matter like how much you know about a topic or you do, you're always going to be able to learn things from people. And that's one of the things about doing live streams and like the Discord and everything that I was kind of surprised about, which is really cool. It's kind of like back in college, just with when you're around that many people at all times, you're destined to learn a lot of stuff just randomly. Okay, so and this isn't like the permanent orientation for the joint. I just want to see where it needs to align. Now doing SolidWorks calls it mates. Here they call it joins. SolidWorks does a much, much, much better job. Like some of the times it just like doesn't count that it was clicked. and you have to like redo it, or double click OK, even though you don't like do anything different. Or like that, you have to click flip twice, even though it's back to exactly how it was. Like that type of stuff's really annoying. How many watts are the cartridge? Like I said, I forget. I've tried desperately to find the order from where I bought these. I think it's like 13 amps total, and that's at 100 and it's North America, so like 115-ish volts AC. So that is perfectly in line. So we need to align the heater with this. So I guess just trying to think of which way makes sense here. Maybe what we'll do is actually rotate this and capture it here. Because I know it's under 15 amps because this was before I actually moved to the office here. So it had to work at my home electric. And that was on a 15 amp breaker. So it needed to fit there. Oh, I know what I'm going to do. Let's do the holes first, so then we can reference everything to that. Yeah, I like that. Sure. Okay, so I believe these were a 1/4 inch, so let's just do like a 1/4 inch hole here. Uh, And the way it forces you to do projections is also something that's really different with SolidWorks. That I actually don't mind how it does it here. SolidWorks is kind of globally done, which gets you in trouble sometimes, but I just always forget and have to do it after the fact. Uh, okay, so distance away. Does that really matter? I don't really think so. As long as we're not too close to going into the actual area, I don't think it matters too much. So we'll just base it off of these. So let's make all these equal. So maybe 0.3 inches. We can do that for now. And I guess I'll just do these all the way through. Tapping a blind hole in aluminum can be, or really any metal can be kind of annoying. So I might end up just drilling a through hole. We'll see. Okay, so now that's what we can base all of the other joints to, which will make it a lot easier. And like sometimes it lets you do it a full mate, but then that time it fixed it distance wise. That type of stuff I have not figured out fully with Fusion yet. Which, I mean, I'm sure there's way to accommodate that, but for some reason AliExpress decided I'm now expecting this in Hebrew. That's funny. If you suspend the hot plate in between the frame by using Kevlar wires, yeah, right. Might as well just go full out. No, I like a Heeds approach. We just use some sort of nugget to stick through. Um, just have to use some sort of oh yeah, if I'm doing that, then they don't even have to be tapped. So that's another reason that makes it easier. Um, yeah, so like, this is the type of stuff that's annoying with Fusion because it's like it says there was already a concentric mate, but it let it move, which means there clearly wasn't a concentric mate. Okay, and I'm not going for like perfect accuracy here with this, because it's obviously going to be mainly cut by just by hand. So as long as the dimensions are roughly accurate, that's all I'm really going for. Okay, so now which way do we want? I guess we can mate this now here and just build it out one side by one. So let's move this. And then it does like weird stuff like that. Like it thinks that I wanted to rotate it out this way for some weird reason. I'm just trying to get the orientation right. Like that. Now we can move it here. They do that tool all the time, random languages. My 3D printer uses a ball mount, but that needed to mechanically separate and allow for thermal expansion. Yeah, the problem is this is going to be really hot, like 300 C, and not a lot of thermally isolated components will go that hot, which kind of makes it a little bit rougher, but we'll see. Again, I'm not overly concerned, but the more we can do, obviously the better. So yeah, what I do a lot of times is I get the first mate like that, and then we'll just do an as-built joint, which clearly isn't the best way, but it works. Okay, so now let's copy this, and then the one thing I really don't like is how if you paste it, it automatically links the two together, so you have to do paste new, or both of their cuts are tied together, which has screwed me over many, many, many times. I understand that sometimes it decides French. Yeah, I've never had that happen before. I guess they value the whole American language. That was a joke if no one caught it. Okay, mate, these two, yes. Okay. Now we need another one of these. Now this one, since I'm not going to be cutting, I can just do paste. I don't have to do paste new. Which, I mean, realistically doesn't matter. So now I'm going to have to cut this, which how am I gonna figure out what's that neat feature where the part floats into place? This calls it a joint, but SolidWorks and most tools will call it mating. Fusion, I really don't like the way they do it. It works good enough, but it's not very smart. Like SolidWorks lets you do two mates at once or even three, so you can fix it all at once, where here you have to do it separately. So now how best do I cut down this? Oh, I guess I can do this first, so I don't have to worry about that right now. Whoops. It calculates the way it should fit together. Yeah, so basically you select like the two features you want it to mate, and you can select different motions like rigid, revolute, slider, cylindrical, pin slot, ball, and then it'll move it to it. SolidWorks, you can completely constrain it in one go. Here, I don't know why it's kind of not very intuitive. You do like an as-built joint, which just fixes it right into place, which overrides the previous one, which, I mean, I guess isn't a big deal, but it's kind of annoying. So now here we'll do a planar joint on this side. So now this should be fully fixed on this side. Okay, so now to cut this, it'll be much easier now. So let's put the sketch, and now we just need to get what the distance is here. So let's project here, and this edge, and that edge. And now if we do a line here, and we can collinear it. It's not over constrained there, pal. And it's like stuff like this Fusion does. Okay. And then now with that distance, now all we have to do is draw our squares or rectangles there and make a distance here and here. Oh, that is not perpendicular. Really? Oh, it's because it just so happens to be the midpoint. Go figure. So now we'll make that equal and that equal. You really can't do it because I said extrude all. Really? So like there, it literally couldn't calculate the distance that it needed to extrude, which really shouldn't be a thing, but whole heck of a lot cheaper than SolidWorks. So it's hard to complain too much. Okay, now let's do one more. Now this one, let's take it from here. And that one, I guess. Oh, crap. This one is going to need to extend to give this room. So let's get rid of this. Completely forgot about that. And now the extrusion's gonna complain. No? Okay. So now this one, we will not paste new because we want those to be the same length. It's funny, not many people must like me doing mechanical stuff. Not a very popular stream. I honestly don't care too much because it's forcing me to actually do this project without just getting bored like I normally do or putting it off. So I do not mind. Anywho, catch you later, everyone. 2 a.m. Alright, man, I'll talk to you later. Yeah, it's still Not too late here. Okay. So now it's just doing it for the other side that needs it to extend down. So like I said, the wire sticks out here 1.5 inches. So maybe let's cut it like 2 inches, I think, and see how that goes. And in theory, I only have to cut this side because the other one's referenced from it, so it's going to cut automatically. We'll see if that actually works though. And apparently it's not going to be able to calculate. Yeah, so it automatically does that. Oh, I don't want to, I made that too big because we have to have this nugget. So let's see how long this is. 0.78. So let's do like 1.25 inches instead of 2 inches here. Now copy, paste that again. Oh. All right. Hey, Heat, if you're still in the chat, do you do much mechanical design? I know your main thing lately has been doing the electronic side, just kind of curious. And I hate how Fusion just like freezes like that after you do something sometimes, which I guess is because it's somewhat cloud-based. I honestly don't really know. All right. And, oh, I guess we can add this too. Make that. Actually, never done any mechanical stuff. Gotcha. Well, how quick you've picked up on the whole electronic side, you might as well. Though I guess it really depends on if you have much of a need. What's funny is, like, that's what my degree is, except I hired somebody to do all the mechanical work. I'll do, like, simple stuff, like modeling up, like simple enclosures or modeling like a PCB outline. But anything more complex, especially if it's like injection molding or sheet metal stuff, I don't do that. Just it's something, especially the manufacturing side, that's like so involved and it comes with like a lot of experience. 3D printing stuff's obviously pretty easy because you're just printing that part directly, but mold design, that's an art in and of itself. I only did some very simple stuff for 3D printing, need to learn more, but there's always something, yes, for sure. Okay. Oh, that did not work. I think we have a problem there. Um, I'm just looking at SolidWorks pricing, not inexpensive. Yeah, I mean, honestly, if you're not trying to get into doing it industry wise, it doesn't, there's no way to justify it. I mean, Ray, who does our mechanical work, he's using SolidWorks because Fusion, I mean, especially. Okay. Why did you not like stuff like that? Oh. Why will it result in conflict? But yeah, for simple stuff, especially if you're just learning. Oh, it's because I still have the as-built joint. Oh, get out of here. Oh, but which one is it? I think it's that one. No. Then I'm just gonna get rid of this and start over. Oh yeah, mold is something else entirely. I can totally see that. Yes, for sure. That's something I'll never get into again. I mean, I know the basics just from school, but it's like anything until you actually are doing it for real projects, you don't really ever actually learn it. At least not to the extent you need it from school alone. Okay. Now we're good. So do the as-built joint. These two, yes, yes. There are 12-month free licenses in some small businesses, startup ones, but they don't seem to care about the low end. I've mostly seen Fusion professionally. Yeah, I mean, I've never seen Fusion professionally. I mean, like I said, I guess technically I'm using it professionally because I do it for jobs for work, but never anything involved. SolidWorks is still, I mean, it's king in the low end market. You still, any sort of simulation, you're going to have to use ANSYS or once you get higher up, Creo, Rhino, stuff like that. But it depends. And they have the startup license, but it's still really expensive compared to like Fusion, which is why it was kind of funny when people were, oh, that I definitely need to paste new. When people were all up in arms about Fusion increasing their price to like, I think I'm paying like $600 a year. And it's like, I don't know how people can get that upset. It's like, obviously, at some point they were going to have to monetize it. And it's like, that is so reasonable in this industry. So I mean, I'll happily I'll happily pay that just because there's no alternative that's even remotely there. Oh, why did you complain? Um, why did you complain? I have no idea. So if I do this one, then I can just paste it straight up. So let's just do that. Keep Fusion from getting mad at me. Okay. And then 100% opacity. So then, like I said, so here are the wires, which right there is the bending point to which is like an inch and a half. So that's where the wires are essentially. How do I get. There's normally a side menu here to get rid of all the joints. Um, okay, maybe we're not going to be able to get that. I don't know. Oh, here we go. Joints. There you go. So basically, the wire is going to come out here and then dip straight down and then go into the electronics area. So I think that works out pretty well. Let me see exactly how wide this is. 1.25 inches, so I guess we do need to make that a little bit longer. My second job I was working at install CAD one of the Canadian railways I did use to design my new deck and print the plans. The city was super impressed. CAD is the 2 2D software from Assault. Oh, gotcha. Yeah, I don't the 2D side something I never got into. So let's make this. Oh, yeah, that nugget's on there. So it is supposed to be what it needs to be. So let's do 1.75. There we go. Okay. So yeah, that's looking super nice. I'm happy with that. And then these are just little caps. So you can actually have the bare screw in there. And I'm planning on putting a like acrylic panel on the outside of all of this that I can mount the switches to, that I can mount all the other stuff to. So I think that'll work out pretty well. Hey, Johnny, just in time for the fun, I guess. Or is her people use Autodesk Inventor? Yeah, for 2D, I always AutoCAD still the king in my experience. Okay, so from here, now we just have the vertical pieces going down. And like I said, we'll have a acrylic panel on all 4 sides. We'll mount the power cord on the back, and then the front instrument panel, control panel. I still honestly haven't really thought of what all that's going to be yet. So now, Ahid, let's look for what you were talking about. So let's look at, it'll be in raw materials. I think it'll have to be a ceramic to be high temperature enough. Let's see. Maximum. Okay. What is 300C to F? So we need like 600 F or above. So any of these. Lady McMaster. Why? I mean, it's super expensive, obviously, but oh gosh, these are really expensive. Oh boy. Yeah, so this isn't happening. What's funny is I need just such a small piece, like 12 inches is way more than I would need. And what, we need a quarter, so yeah, $58, that's not happening. So why didn't that show up? Oh, it did down here. Okay. Okay, this works, because 3 inches is probably enough. Yeah, McMaster is amazing. They have it's amazing for prototypes and to figure out what you need, but yeah, it is so overpriced. So let me do just a 1/4 inch diameter. We get here the next day. You take into consideration active cooling. Yeah, that's going to be next for sure. They'll only ship to companies in Canada. Oh, yeah, I honestly don't know. I've always shipped here. So where's my transistor? So the board is, so like we put the board on, and then when it's reflowed, we'll pick it off by hand because there's no way to cool it down quick enough, and it would be super inefficient to have to heat that plate up and cool it each time. But I do want to have fans just to cool it down for the next board to go on if we're doing multiple. But yeah, definitely going to work on that after. So what's the cheapest here? Probably this. $30 for 12 inches. Because how much do we need? If it's 1/2 inch thick, these will now no longer be through holes, they'll be blind. So if they're halfway through, that's a 1/4 inch nub. So 1/4 inch, 1/2 inch. So it's 3/4 of an inch total. So where am I going? So 3 inches is plenty. So we can go with this. The only thing is, how do we cut this? Does anyone have any experience cutting alumina silicate ceramic rods? Lava and Wonderstone. I'm assuming. What about having a second isolated surface with air gap to slide the boards onto? Second isolated. Yeah, so it's going to, and this is now, I'm thinking the way that I did this with joints now, it's going to make this kind of a pain to lift this up. But basically with the washer here, it's going to be above this, so we'll be able to slide them on and off like you're saying. I don't know how much, if anyone's following what Ahid said. The problem is to show it, I have to break all of these joints, which isn't going to be like easy. But I kind of have to. So first, let's do this. Let's extrude. Okay, so now no longer these are through holes, so now they just go half the distance down. Alumina can be machined with bonded diamond cooling, with tooling. I've sawn, drilled, and milled with no problems. Okay, so that's what I was going to say. As long as I use a carbide bit, it should be fine, which is what I was assuming. And it's not like these have to be accurate at all. So let's figure out now, how do I undo these joints without it being an absolute nightmare? Yeah, it's gonna start moving everything. This is the part of nicely product photos. Someone aware of an alternative in Germany. I cannot help you there. So this is where the stuff I always would have a tough time doing mechanical design, like making changes parametrically, because when I delete those joints, it's gonna move everything around. You undo the joints all at once by pressing Control Alt Delete. Yeah, right. Crap. Because what I want to do is I want to lift this up with a washer and then use the ceramic rod so I can show what Ahid thought of, and I think will work amazing. But I honestly, short of recreating this without basing it on these joints, I don't know of a really good way to do that, but it's probably not worth it. So let me just do this. Let me just show you what the idea is. So basically, let's pretend that this is the hot plate. No, let me keep doing the sketch. So this is 0.25 inches. Whoa. So this is our hole. So we have 3 of these. I'll just put one here. And, oh, and it's going to be a through hole. Whoops. Nice going. and it didn't join. Okay, so this is what's on the hot plate. So basically what I think we'll do, so taking one of these alumina silicate ceramic rods, which high temperature resistant, so not much temperature, not much heat will be transferred through this. What we will do is essentially we will jam that rod in here, and we'll probably need some sort of high temperature, low thermal conductivity adhesive to make sure it stays. So that will be now on all three corners. Then we'll get a 1/4 inch high temperature washer that sits right here. So I guess I can draw this too. So we'll have a high temp washer that chills like this. Don't join that just to make it visually apart. New body. So then there'll be a washer here, and then that will slot into all of these. So basically, this will be fully thermally isolated from the aluminum extrusion, and it'll still be held in there pretty good. I mean, yeah, it'll be completely thermally isolated. I was gonna say this can be touching the metal, but that's fine. So yeah, that should work good. And just to clarify, Ahid, this is basically what you were talking about, right? I mean, even if it's not, this should work perfect. So it got me here, but I'm pretty sure this is what you were talking about. So we'll just pretend that that is set up here, and this is lifted up by a millimeter or two. So then what station 240 said is true. We'll be able to slide onto here without too big of an issue, slide on and off. Because there's the gap here, which should help. So now I guess, and I don't know how tall this is actually going to be. I don't think it really matters. But I guess let's just do an arbitrary slot. Yeah, that was the idea. Sweet. Yeah, really, really good idea. That is not what I was thinking of. Yeah, it's always kind of funny with stuff like this, and obviously a lot of people make it work, but like people who are just doing like prototypes and like a board here or there, they do like the full like toaster oven thing. And it's like, sure, especially if you're doing a lot of boards, I can see that being better than this because you can do double-sided boards and higher throughput potentially. But for like one-offs, man, I honestly, I mean, we do a lot of prototypes. I mean, we're doing, I don't know, it depends on the month, but we're spinning probably 6 different designs, probably 4 to 6 different designs a month. And it's like, unless it's a double-sided board or it's a really big board, we're never firing up our main ovens for them just because it's a waste of energy or electricity unless we're running it already. This thing is just amazing. Like, hot plates are the greatest thing ever. They work so well. I've used one of those 100mm square hot plate things. Works for me. Attempted to automate with a temp sensor. Yeah, the problem I've heard with a lot of like the Chinese ones is they just don't have enough power to heat it up quick enough. And to be fair, this for lead free, the total time to reflow is like 5 minutes from cold, which is too slow, which is why I want to mill out a lot of the surface area here. But it's fast enough to where you don't have an issue. So what I'll do a lot of times, that's what I'm thinking of doing with the PID loop here, is I'll start it at like 100 degrees or 120 degrees, put the board on, wait like 20 seconds, then start cranking it. And I think that will probably give a pretty decent profile. Because right now, I mean, it's certainly not great, but I've never had an issue. The key is as long as you're using paste that doesn't mind an extended soak time, the key is you're never going to have like tombstoning issues or anything. So it works out really well. Okay, so obviously the length here is we can change, but there's no real sense of doing that right now. Let me get rid of these again. And then just to show this again, so my plan is to use... Oh, it doesn't let you drag that? Lovely. So my plan is to have an acrylic sheet that mounts over all of this. And like I said, these caps are just caps. You remove them, so they won't be an issue. So... Oh, why did it do all goofy? That's another thing. Whatever, it's close enough. It's just a show. SolidWorks will automatically do the main volume, so you don't have to do it separately. So basically there will be a thanks, I have to go, but it'll watch the rest tomorrow. Curious how it turns out. Awesome. Yeah, I hope you enjoy it. I appreciate you being a part of it. We'll catch you next time. So yeah, there's going to be acrylic panels, and they probably won't be. Probably 125. So that's going to be on all four sides. On the back side is where the power cord's going to come into. And then the front side will be the panel with the display and whatnot. I still have no idea what the actual control of this is going to be. I'm thinking just for ease of use, I'm thinking what might make the most sense is simply having like an ESP32 that will connect to Wi-Fi, and any of the settings can be adjusted over like a web server or just a web page, and then simply just having like some on-off or some super simple controls on the front that lets you start it, maybe show a couple profiles. Anyone have any thoughts? Because doing like an actual touch screen and making it all pretty, I think, is kind of a waste. I think it makes way more sense to do it through like a web server. But I'll be curious if you guys have any thoughts. Hey, Hybotics, glad to have you now that you can watch streams again. And then mounting the fans. That is something I don't exactly know what to do. What I was kind of thinking is if we put two cross braces that go across here, like if we have two cross braces, why is it not letting me drag? Okay, if we have two cross braces going this way, we can then put an acrylic panel and just put like 4 fans on it that are blowing straight up at this. Then mounting the PCB, just put a couple mounting holes on it, and we can mount it to any of these legs. I think that works. Yeah, I think that works. Does any web control is nice just have a manual shut off? Yeah, for sure. I'm thinking have a manual like on, and then maybe even a temperature readout or something, and then a manual off. I think that makes sense. And then does anyone know what are the back panels called that take in like the IEC mains plug and then they have the little power switch? Presumably you can buy those straight on DigiKey. What's the plug called? It has a yeah, it's this one. The NEMA 5, which goes to a certain. The plug is C13. Yeah, C13. Okay. So then maybe we look up a C13 switch back panel. Nintendo Switch? How in the world does a Nintendo Switch come up from that? Does anyone know what I'm talking about? It's like what you would literally plug in. It has the interface that has the power on off switch, just because that's the easiest way to make it go through a bulkhead. Um, C14 is the one in the device then. Okay, maybe that's what I need to look at. There we go. A heated, man, you're on top of it. Oh, bit, but still, you got it too. Okay. Sweet. Okay. So now let's see if DigiKey, now that I know what to search, C14. Power entry connector. So that's what they're actually called. Perfect. So now current. Geez. We're going to be a little limited. Oh, 15 is common. Okay, cool. Filter by price. I spent like half a day figuring that out. That's funny. So now let's get one with a switch because we obviously want that. Oh, circuit breaker. That's cool. Magnetic switch, so on a power fail, it turns off. That's cool. Oh, they're not too expensive. Unfiltered commercial. So what's the actual filter in here? Is it just like differential or... So they say it has a filter, but they do not actually say what it is doing. Does it have a step file? That would be really nice. Sweet. Pretty sure it lets you do that, no? Alright. Well, let me upload that. I could have sworn it lets you do that. Oh yeah, am I going to be able to import this? Because it didn't let me do it at first. Hopefully. C1314 are officially for low temperature devices. For higher temperature, but in theory it's going to be low temperature because it's completely isolated, but I guess we can see. I'm sure that'll make the pricing massively different. Would you say C15 or 16? Oh, they don't even have C15 here. Is there another name for it other than C15? Oh, is it this? Yeah, let me know if there's another name. Yeah, I don't think it should be a problem, but I'm curious. Oh, it uploaded. So let's see if I can actually add this stupid thing in. Let me drag it in that time. Perfect. How weird. I don't understand it. Oh, Ahid. Um, since I'm always telling you in the patrons channel about the music and concerts, so I'm listening to like reggae now. I don't know if you have that. So like Bob Marley style, I'm listening to Revolution right now. It's like super like upbeat, kind of like chill music. I really like that. I've been kind of on a kick of theirs right now. I just said right now like 4 times. I guess that's my word right now. So 1.54 by 1.56 with tolerances. So just do 1.55. I'll drag it over here. I know only the German name, not going to pronounce that. Basically the one you picked with additional notch at the bottom. Okay. Yeah, I don't think I'm going to worry about that whatsoever. No, I think I like it this orientation. 1.55, 1.1. Last concert had like 20 people. There are some local bands, but yeah, concert scene has been slowly firing up. Yeah, it's pretty much in full bore here, which is pretty neat. Why are you not letting me cut through all anymore? What's a concert? Yeah, here in the States, it's been pretty wild. Like all the bands are like they're making up for lost time. So it's pretty mad. It's pretty mad how many there are. And like the concerts that we had signed up for before COVID, now they're all like rescheduled. So that's pretty much all the ones been going. Oh, was that not fixed? Whoops. Really? Really? Come on, Fusion. set as components. I have no idea. I guess I'll get rid of the previous joint that I did with it. And now it's not even at a correct angle. Lovely. I don't know why that wasn't working earlier. Weird. Oh. Like, that is such a bug. Like, you literally just have to click flip twice so it goes right back to how it was, and then it lets you do it. Now this, we're not going to be able to actually mate it really well because it's a snap fit, but it really doesn't matter because this is really just to show it. Okay, so that's all mated. So we'll have power coming in here. Oh, that's cool. It shows you live, neutral, and then presumably earth. So we'll have power coming in here. Probably have earth go straight into here, tie it to the aluminum extrusion, which will be all tied together. And then I guess I'll tap one hole here. So we'll, oh, actually, technically we want this to be on the other side. All right. Well, Ahid, you missed me realizing that this is on the complete wrong side. This should be on the back here where the wires come in because that's where the circuit board's gonna be. But I don't think I'm really gonna care about that right now. I just really want to have the gist of this fleshed out and then can kind of reset it up properly. But yeah, what do you guys think for fans? Because I want to have like 4 pretty powerful fans shooting straight up here. And we can have like the, I guess we have to think of where the airflow is actually going to be exhausting. See, this is where having heat sinks would be nice, but that kind of defeats the purpose. Because like I said, eventually, hopefully, I'll mill out some channels here. Like this. So that'll kind of act like a little heat sink channel, or at least give more surface area. So I have to go. We'll see everyone another time. I need to take my computer apart. Still battling that, huh? Well, I'm glad you're able to come by for a bit. So maybe what makes the most sense is mount the fans here at an angle so they're blowing across here and then it exhausts out this end. I'm thinking that makes sense. So basically, there'll be a bracket here that angles them at a 45-degree angle so the air hits here, and maybe even have like a perforated, yeah, like a perforated sheet on the back. Okay. I managed to fix my PC just by starting to take it apart. Gotta love computers, huh? It's like the number one thing. Did you turn it on and off again? So I guess if we're gonna plan on the fan side, then I guess it does make sense to redo this. So let's get rid of, I guess, all of these joints. Oh, this isn't gonna be near as hard as I thought. What's funny is this is actually gonna end up being kind of a pretty neat control board because it's gonna have to switch the 120 mains, obviously, but then it's also going to have 12 volt for the fans. So the electronic side is going to be pretty decent, and this I really don't care if it's super exact. Why not enclose the bottom of the hot plate with the exhaust fan so it'll heat up faster, then turn the fans on? That's, yeah, yeah, that's a much, 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 much better way. So basically make like an enclosed box and then it forces the air through and then it would exhaust out the top here. Is that what you're thinking? I mean, I don't know if it's gonna, I don't think it's gonna heat up any faster just because I had tested. So I had tested this setup with the mineral wool here and with it just on like an open surface, and it really didn't affect it whatsoever. Just because there's so much heat going into this hot plate, it's just going to the heat transfer to anything else is so minimal. I don't think it's gonna affect it too much. But yeah, I really like that idea. So let's move. Oops. Move this. Yeah, this ends up turning out pretty cool. This will be a neat, like, actual formal video, I think. Problem is, like, for people wanting to do this, unless you know someone or you have a machine shop to do the extrusion for the hot plate, you really can't do it with any like DIY stuff because to do an 8-inch long drill, you can't do by hand or even in a normal drill press. You have to have either like an industrial drill press or a mill. One of my buddies used to work at a machine shop and he did it for me. And then even then you actually have to ream it. So you drill it a little undersized and then use a ream to make sure it's exact. That's the biggest pain of this, is if you don't have that, you really don't have a chance of it working. I would use an aluminum plate and bolt the cartridges to the bottom. Yeah, but you really, and in the data sheets for these, they have to be fully enclosed or else they'll burn up because you have to have really, really good contact. I mean, I'm not saying there's not alternatives, but they're pretty specific. Like the tolerances on these are really tight. But yeah, I mean, I'm sure there's other ways to do it, of course. Okay, so now this is on the right side. Or by the inexpensive heaters that come with small plates. Yeah, I mean, that's what most people do for sure. But this is obviously the best because you literally have no thermal mass other than the heaters. So power comes in here. So now, where's my... So on McMaster, let's go back to the extrusions and see how we add that plate on the bottom. Orbite looks nice if you make it start selling the extrusion. That's true, actually. That might be a decent approach. Let everyone DIY what they want, and then I can at least sell the hot plate side. Yeah, that might make sense. Okay, none of those. Okay, what am I even looking for? It's how do we... I guess we probably need to have an extrusion here. Yeah, that's what we have to do. So let's copy this, and then let's slide this down. Say like 2.5 inches. Okay, so now this side will have an acrylic sheet. This side will have an acrylic sheet. And now we will put an acrylic sheet here. It's like, this is the stuff that's annoying. This one probably needs to be probably a 1/4 inch. All right, so Bruce, this is what you're talking about, right? So now, obviously, this side has an acrylic sheet, this side has an acrylic sheet, this side has an acrylic sheet. So now we mount the fans in this, which are pointing. Does it matter which way they blow? I don't think it really matters which way it blows because it's either going to suck in air from up here, which is going to be cool, or it's going to suck air from the bottom, which is going to be cool. Either way, is that what you were thinking of? It doesn't matter which way it blows for now, because then it makes basically like a little air chamber, which is constantly blowing or sucking air through. In PC cases, sucking out of case is worse than blowing into case. Okay, so either way, I mean, that's something I would pull across. So fans on one side and grill. Remember, I'm not going to really have a grill because this is going to be the exhaust or intake area. So the fans would be right here. So it's going to push air basically like this, which goes across the entire length. So it'll either suck in this way and then push it, or it'll suck in here and then push it out. Cool thing is we can always flip them pretty easily to try different orientations. But yeah, I really like that idea. That was good. Oh, and I guess also, since this isn't flush, it's also going to come from the sides, which is helpful. Sucking air at 100 degrees. Oh, good point. Yep. Yep. Good point. So we're going to have to push air. Yeah. So it's going, if the fans are sitting here, where's my transistors, right? It's going to have to suck in air like this and then exhaust it, because that air is going to be super hot and that'll burn up the fans. So let's go to DK again. Oh, I guess we could get, I mean, they're not as efficient, but it would save us having to do a regulator to give us 12 volt DC. We could do like an AC fan, because then we're using all the high power side on the AC end. That probably makes sense. So then what kind of width are we looking at? Oh, I can just, because it'll probably want to be about this size. Oh, that's small. 2 inches. Yeah, but it doesn't matter if it takes up a good portion here. So yeah, maybe I do my sketch. So if it takes up here, so that's like 3 inches, so 75 millimeters. So let's look for like 75 millimeter fans. Going to grab some dinner with the girlfriend. Awesome stream. We'll finish it later. See ya, Brad. I didn't even know you were still here. Have a good time. It's a late dinner. And then voltage. Let's do anything in that range. What did I say for the fan? Like 75 millimeters. Oh, wow. AC fans, they're all big. Oh, boy. Well, that might make it a little harder to do this. 120 millimeters common. Okay, it is still common. I didn't know if it was just for DC. And then we don't care about pressure whatsoever because this is open. So all we care about is airflow. And I guess making it not super, super loud. So let's filter out anything that's... Oh, none of these are crazy loud. The highest is 60 dB. So if we do like anything from here, and we don't care about speed control either because this is going to try to cool it down as fast as possible. So yeah, I think AC probably makes a lot of sense. Now we can filter by maybe higher CFMs without being super expensive. 115 versus what? 138. So that's a pretty good price here. Does this have a step file? Sun on fans. I've never heard of them. So hopefully. $120 by $120 by $38. $120 by $28 by thickness anywhere. $38, yes. So even if this isn't the exact one, it's close enough. Oh. Do I have an account? Apparently. Millimeters. 140 millimeter fans push a lot more air than 120. Check that if they AC has them. Sure. And we can check CFM. So what fan was I on? I'll duplicate this. Because what is this? 115 CFM. So let's see what 140 has. That's what you said, right? Yeah, 140. No, they do not. They have 148.5 with nothing. 144, no. It is funny how AC are completely different then. Oh, I did noise. Now let's do it. Oh, but they still... Yeah, how weird. 180, but that's getting like stupid big. And what's the CFM? Oh my gosh. Oh, they're stupid expensive. I guess we could see round. 180, but that's going to take up so much more space. I think we'll stick with 120 for now. Because two of those, I mean, 240 CFM, I mean, that's quite a bit. Our oven exhaust is... I actually forget what it is. Save. Sorry, I just got a message. 1 second. Okay. Did I download it? No. Why is it not downloading? Oh, I did. Okay. It is funny. It's like, obviously, the YouTube channel is more geared around videos, and I don't get a ton of people on the live streams, but it's funny. Like the couple videos I've done, the couple live streams I've done that aren't specifically with like electronics design, not many people watch them. It's like the majority of the audience is like so tuned in on the electronic side that when I do anything different, it's like, nope, not gonna watch it, which is funny. But I've kind of realized recently it's like the video side is where obviously the audience is. The live streams are just when it kind of makes sense. So I'm not really making them like a super big priority anymore. But I just do them because I really enjoy it, and it keeps me from procrastinating on things like this. Oh, that's big. I didn't realize it was that big. Yeah, heat. I don't think your 140 millimeter would have worked too hot. I don't know if this is gonna work. Oh my gosh. Yeah, I was way off on scale here. I guess it is a small little hot plate setup, but that's so much bigger than I thought it was gonna be. I thought we were gonna be able to fit like two of these in here. We're barely gonna be able to even fit one. But I guess that's fine. Yeah, sense of scale, right? That's really funny. Probably that will make the fan very, very unhappy. So I'm assuming we'll have to move it down here. I've posted some more photos over in the Discord of someone's approach. Oh, sweet. I'll check that out. Oh my gosh, that is sketchy. So, oh, it's cartridge heaters. So why are there two different plates though? Still, I don't like the approach with the heat sink because you're just losing all your heat from here to there when you're trying to heat it. It's like, yeah, it makes it nice for cooling, but that's about it. Holy cow. Got a dang wind turbine. That's really funny. He drilled it all. So he drilled half through it. I still don't know why he used stacked pieces. That seems weird. 500 watts of heater. Yeah, that thing heats up real nice. And that is something I've thought of, is doing a little bit more, but it heats it up pretty close to a full profile with mine. And any more, I have to have a separate breaker for it. So how is his? Dang, that is pretty impressive though. So that's the advantage of it being a lot smaller. So yeah, his definitely beats mine on the profile side. That's really cool. But he's limited to very small boards where ours is definitely not. Like his is almost, unless you're doing it for a very specific board, it's almost useless. But if you're doing them small enough, so add a thermo. Oh, for sure, I'm going to add a thermocouple. Um, Potentially two, one to the board, and then also one to one to the plate, and then potentially one to the board also. But that is really cool. Okay. God, I just cannot believe how big that fan is. You do lose all sense of scale. Let me just make sure that is 120 millimeters. I'm assuming it is. Oh, it's technically 104, so maybe they use a standardized size. But either way, I mean, it is fine. Hi from Greece. I found your channel 3 days ago. I really like it. I'm currently doing my thesis and trying to master PCB design. Well, if you manage to master PCB design for your thesis, you might be giving me lessons. I'm just kidding. That's cool though. I'm glad you found the channel. Okay, so this will then suck in air here, or I guess from the whole bottom, we'll stop the acrylic panel a little bit. It'll suck in air, blow it through an opening here, obviously, and then it'll exhaust the air all around here and at this exit, which essentially will kind of increase the pressure. So this should be pretty solid, especially if those channels are there. Not exactly master, but I couldn't find the right word. Yes, I hear you. I'm just joking with you. Okay, so that is that. So then now this makes it super easy to add. Oh, so we'll move this down because obviously we don't want this in the hot area. So we'll move this down, and I guess Bruce, right? We should move also. There's no sense in having this cavity bigger than it needs to be. I guess the only disadvantage is I'll measure how hot it gets to make sure it doesn't melt anything, but I don't think it will. We should have this up higher, move this below that panel, and then we'll mount the PCB. Whoops. We'll mount the PCB to the bottom of this acrylic. So let me do. So we'll mount the PCB right in here. So power comes in, it'll go straight into the PCB. It'll shoot up to the 6 heaters. And I haven't figured out how those are going to be set up. I'm thinking 6 solid state relays seems obnoxious. So maybe do like 2 paralleled in each. So do like 3 solid state relays with 6 connectors, just to save cost and annoyance. So power comes in, goes to the PCB. 3 solid state relays jump up to here. Power goes to the fan. And then wires across here to the front panel. The front panel has some sort of digit display and a few buttons. Mount lower, yeah, make a tunnel. From what? I'm just trying to remember. So, like, sometimes if a part does move, like, I can have my hand, I can have my hand, like, right here trying to place with, what am I trying to say? Tweezers. I can place with tweezers here, and it's never like super hot. So I don't think the conduction or radiation from this is really high. So I'm thinking that all of these are gonna be fine. I really don't think it's gonna get that hot. It's only anything that's in direct contact is going to heat up, but I guess we'll see. Button. Alright, so I think this is probably a good spot to end here. Just because, whoops. How does that even happen? How in the world does that even happen? Well, now my comments are all messed up. Okay, there we go. Sweet. So yeah, I think this is a good place to end. what I'll probably do is before the next stream on this, I'll clean this up so the mates actually make sense and the washer lifts that up. But I think next will be just finalize the little mechanical stuff and then probably start on the PCB. It'll be a fun PCB. I don't do a lot of mains stuff, so I think that'll be interesting. But yeah, sweet. That was fun. I hope you guys enjoyed. I know it certainly wasn't as popular as my normal ones. I guess I have a tough crowd. It's electronics or nothing. But for those of you who stayed, I hope you guys, Mayton, any chance to have the EMC series? Now it actually is soon. So the next video next Saturday is going to be the introduction on that. And I know you've been asking literally every single stream. So yes, it is very soon. The next series will be the intro, going over just kind of the series itself, doing a couple tests on the buck converter. And then actually the next like 2 or 3 topics are actually going to be based around that buck converter for it. So yes, it will be very soon. I am glad. It's been a very long time coming. But sweet. How often will you stream? Like I said, my channel is solely based around videos. So streams are just when I have something to stream. I try to do videos every 2 weeks. Streams are whenever I have something. So I'll probably stream this next weekend just because I want to get this finished. But it depends. Bruce, as a newcomer enjoying these, sweet. Yeah, I mean, like I said, whenever something comes up to where it makes sense to stream and it doesn't make sense to do a full video, I'll do it. But yeah, otherwise next week will be the EMC intro. And if you, whoever's new here, also if you haven't joined the Discord link will be in the description, or at least it should be. And also the link for my Patreon is also on the description. Anything there, any support is much appreciated. But otherwise, I hope you guys enjoyed, and I will catch everybody, like I said, next week if I stream, if not the next time. But yeah, I will talk to you guys later. Have a good one, everyone.